Hello, my name is Advik, and I'll be going over the Math Module 2 worksheet. Yeah. Okay, so the first one is the graph of x squared plus x plus y squared plus y plus 199 over 2 is a circle in the xy plane. So what is the length of the circle's radius? So the hard way, without using Desmos, is to actually go through everything. So let me get the pen tool. So right now you see that we want to try to get it into this form right here. This is how like circles are typically expressed, and over here we can find the r squared at the end. So that's why the first step that we're trying to do here is we're adding 1/4 so that we can complete the square for both the x and y. So when we add 1/4, let me clear that. When we add 1/4, we can get, and we factor it after, we get x plus 1/2 squared plus y plus 1/2 squared is equal to 199 divided by 2 plus 1/2. And the 1/2 on the right side just comes from the two 1/4 we added to balance out the left and right side. So after that, we can add up the two fractions on the right, and we see that we get 100. And because this goes back to the form that we mentioned earlier, we know that r squared is equal to 100, which means that the radius is 10. But I personally would not do all this work on the SAT. The SAT is all about being as time efficient as you can, while trying not to make any mistakes as you can. Like, for example, you might put like 1/2 instead of 1/4 here, which would be like an honest mistake, but it could like cost you the entire answer. I mean, this is going to be multiple choice, but like some questions are free response, so you want to watch out for that. So what I would do on the year is I would just go to Desmos, and I would just plug this equation in. So x squared plus x plus y squared plus plus y is equal to 199 over 2. So over here we can see we have the graph of the circle, and now if I click on this and look at the furthest points up and down, you can see I have this point right here, negative half 9.5, and negative half negative 10.5. Well, I can just do like a quick calculation. 9.5 minus 10.5, that's 20. The diameter is 20 because those are the two farthest points. So if the diameter is 20, that means the radius is 10. And for me personally, like, I'd rather just quickly Desmos through everything than do every step by hand myself. So that's the shortcut that I would use for this question. Okay, let's see the next question now. Let me move this up. Next question. If C is a constant and the system of equations shown below has infinitely many solutions, what is the value of C? So the two equations we are given are negative 7 plus 2f is equal to CG, and 21g plus 21 minus 6f minus 15g, 21g plus 21 is equal to 6f minus 15g. And so we want to pay attention to the word infinitely, because what that means is that for two equations to have infinitely many solutions, that means that the two equations that they've provided are the same line. So these should give us the same line when we graph them. If they're parallel, that means they have no solutions in common. And if they're not the same line, that means that they're just gonna have like one normal intersecting point. But here we're looking for two identical lines, just expressed in like two different ways. So what my approach here would be like, the first equation looks much simpler than the second one, so I want to try to like simplify the second equation. So the first thing I see is that the entire second equation is divisible by 3. So what I did here is I just divided by 3. I just divided everything by 3. So then I get 7g plus 7 is equal to 2f minus 5g. Then I want to move all the g's to one side. I chose the right side because that's where they are in the first equation. And also I moved the f's to the left side because that's also how they are. So 7 minus 2f is equal to negative 12g. So yeah, just subtracting 7g from both sides and subtracting 2f from both sides. Then I just multiplied by negative 1 because I wanted to get it in the similar form as the other one. So times negative 1. Sorry for the writing. I'm on a stylus. It's not the best. And that gives us -7 plus 2f is equal to 12g. And now we can see that we bring this like equation from here down below. We have like two equations that look almost identical. It's just that over here we have 12 and over here we have c. And now all we have to do is that from that we can just tell that c is equal to 12. And that's the hard way again. I would not do all this algebra though. What I would do is I would just go into Desmos. I would just clear this out. 7f plus 2 or 7 -7 plus 2f is equal to cg. Oops. Oh yeah. Here's the thing. You want to make sure instead of putting, because Desmos doesn't know what f and g is, just do x and y. So like over here, let's just say let's make f be the x-axis and g be the y-axis. So let's just do -7 plus 2x is equal to cy, and then let's do 21g plus 21 is equal to 6f minus 15g. Oh, oops, yeah, I forgot. Y, x, y. So now you can see that we have like this slider here, and what you can do is, because like most questions are gonna be multiple choice, you can also just use this scale out answers. So if we move it here, we can just play the animation, see if that hits. We see that towards the end, we're getting closer and closer to the actual slope. So if we actually move this all the way to end, that's 10. That's 10, and we see that doesn't meet it yet. So we can just add it in this range. Let's say let's go from like 10 to 15, and let's see. Now you see we're getting closer and closer. So now I can just like manually place around, and we'd be like, oh wait, 12. C is equal to 12. They have the exact same line. And that's like a quick tip that you can use on multiple choice questions, and just check your work if you need to. It makes it a whole lot easier when you can like visualize everything. Okay. Now question number 3. So one solution to the given equation can be written as j minus the square root of k, where j and k are constants. What is the value of jk? So the first thing you want to keep in mind is the word solution, which means that because we have a quadratic right here, we probably need to use a quadratic formula. So we take out the quadratic formula. X is equal to -b plus minus the square root of b squared minus 4ac divided by 2a. So then we can plug in our numbers. B is -12, a is 1, and c is 7. So we're plugging our numbers here in this right here. Then we're just simplifying it. You have a calculator, so you don't have to actually worry about like doing all this by hand. So we get 12 plus minus the square root of 116 divided by 2. And then you realize that you don't have anything in the denominator over here. You have 1 in the denominator, which means that you should probably be able to factor out a 2 from here. And 116 is just equal to 4 times 29. Let me make that a bit more clear. That looks a bit weird. Yeah, it's equal to 4 times 9. So which means that you can factor out the 4 and take the square root of that, which is just 2. So you get x is equal to 12 plus minus 2 times the square root of 29 divided by 2. Then you can just divide a factor of 2 out from the numerator and denominator. So you get 6, and then 1, and then just the square root of 29, and then nothing in the bottom. So you get x is equal to 6 plus minus the square root of 29. And it doesn't really matter here, plus minus, but because it is asking for like the one where you have a minus sign, you go to the one over here. So x is equal to 6 minus the square root of 29. So you get that j is equal to 6, k is equal to 29, which means that j times k would just be 6 times 29, which is 174. Okay, question number 4 now. Clear, pen, and now. Okay, this one. So over here, what we're trying to do is, here, I'll read the question first. A gemstone shown in the left is being carved in the shape of a right square pyramid from a hemispherical stone with a diameter of 40 millimeters. The square base of the pyramid will be carved from the base of the hemisphere. The height of the pyramid will coincide with the radius of the right hemisphere. So that's just saying like the height is the radius. And so what is the volume in cubic millimeters of the right square pyramid that can be carved from the hemisphere as shown below? So over here, let's just see what we know. I can try doing like a rough sketch. Like we have, this is our base, and then this is the height. So this is what we're trying to make. And you can see this is the base right here. So how we solve this? So we know that the volume of a pyramid is, or like a rectangular pyramid, is V is equal to 1/3 times the length, width, and the height. Well, in this case, we have a square base, so that means it's just going to be the square, or the side length squared, which is why we have like the number here squared. But before we get into that, how I got 40 divided by the square root of 2 is that we have a right triangle, we have 40, and if you go back to like the reference sheet that they provide you, you'll know that the side, that the diagonal is just the side length times the square root of 2, or going the other way, the side length is just the diagonal divided by the square root of 2. So that's how we get 40 divided by root 2 as our side length. So then we just plug it into our equation, 1/3 times 40 times the square root of 2, 40 times the square root of 2. We repeat that twice because it is a side length. And then the height is 20, which we just get because diameter is 40, divide that by 2, since the diameter is just, the radius is just the diameter divided by 2. And then once we like solve that, we get 5,333.33 millimeters cubed. Okay, next question. There. Okay, so let's read this. The side lengths of right triangle RST are given. Triangle RST is similar to triangle UVW, where S corresponds to V and T corresponds to W. What is the value of tan W? So the first thing I would do is draw it out. So let's draw out two right triangles. Let's draw a bigger one maybe for here. And then RS is the short side, so let's put R here, S here, ST. So we get 20, 48, and 52. And now let's draw the corresponding triangle. So we see that S corresponds to V, so let's put a V right here at the right angle. Oh yeah, I'll include that. And T corresponds to W, so let's make a W right here, which means that this top corner is U. So the thing about tan is that no matter how big or small your triangle is, it's always going to stay the same. The opposite and the ratio between the opposite and the adjacent, or any sine, cosine, they're all going to stay the same as long as like the triangles is similar to each other. So over here, if you want to take the tan of W, that's just going to be the same thing as taking the tan of T, because they are similar triangles. So we got that opposite over adjacent, which would just be 20, because 20 is over here, the adjacent is 48, so 20 divided by 48, that simplifies to 5 or 12, which is just like it's a pretty common triangle. Like you'll see on the SAT a 5, 12, 13. In this case, we just call it like a 5, 12, 13 scaled up. So yeah, now question number 6. Yeah, we have one clear. So this one's I would say is like probably one of like the most work intensive ones here so far, or maybe total completely in this entire worksheet. So an equilateral triangle is inscribed in a circle with a radius of 8 inches. What is the area of the region that lies within the circle but outside of the triangle in square inches? Round to the nearest tenth. So I can just, so what we're looking for is this shaded area, not in the triangle but in the circle, right? So it might seem a bit weird at first, like how am I supposed to know anything about the equilateral triangle in the middle? But so what you can do is when you have the center, you can draw a line right here from the center to a corner, and you'll see that that's going to have the length R because that's the radius. We add one more going this way, and we add one more line from the center to the midpoint of this. And we notice that because this is equilateral triangle, there's going to be 60 degrees. 60 degrees. And right here, we're making this a 30 degree because we're splitting this up. We're splitting up the angle into two parts. So now we have 30 degrees right here. We have 90 degrees right here. We have 60 degrees right here, which means this is our 30, 60, 90 triangle. And that's also given on the reference sheet. So based on that, we know that this is going to be R, like this is R. This is going to be R divided by 2, which is what it says right here. And this is R times the square root of 3 divided by 2. So you could, I don't think the reference sheet gives it out like that, but you can calculate it, or you can just like memorize it, like it's going to be somewhat like this. Just remember the ratios of the sides. So the easy part first, we can find the area of a circle, which is just pi r squared. R in our case is 8, so 64 pi or 201. Then the triangle, we can use area is equal to base times height. And the reason why I put a 2 right here is because what I'm trying to measure is the area of this triangle right here. But we have 2 of them, so I put a 2 on the outside because of that. So let's see. We know that the base right here is r times the square root of 3 divided by 2. And then we know that from our information earlier that this is r because this is going from the center to the point on a circle, and this is r over 2 because this is going from, because we calculated this from our special right triangles. So r plus r over 2, well that's just going to be 3 over 2r, or 1.5r. So now we know our base, we know our height. We see that it's 2 times 1/2 because the area of a triangle is 1/2. But those just cancel out. So we get 8 root 3 divided by 2 times 3 times 8 divided by 2, which is equal to 83.138. And now all we have to do is subtract our circle from our triangle. This is the circle. And this is the triangle. Let's put T. And then we get 117.9 for this question. Okay, this is probably, I'd say like the hardest one on here because it's like, it comes like a bit more like, what do I even do here? But I guess the strategy is to draw lines, like try to like break it down as much as you can and look for something special. Like in this case, what saved us here was the 30, 60, 90 triangle. Okay, let's move on to the next one. Oh wait, I need to switch it. Okay, a sector of a circle is shown with center point C and central angle x. The radius of a circular sector is 15. The arc formed by the central angle x from point A to point B has length 12. What is the measure of angle x in radians? So this one's actually pretty simple. It might seem a bit weird at first, but just remember that the length of a sector is equal to the radius times the angle. And remember, this can only be in radians. So this is only, don't ever try to do this in degrees. It's only in radians. So yeah. So we know that the length of the sector here is 12. Our radius here is 15. So we divide that by, like, we can rearrange the equation. So we get theta is equal to the length of the sector divided by the radius, which is 0.08. And if you're wondering why that's true, then you can just break it down by like thinking about it like this. Like 12 is a fraction of the circle, where the whole circle would be 2 pi r, so that's 2 times pi times 15. So this is like the fraction of the circle that our sector covers, because this is circumference, and the bottom is the circumference and the top is our sector. But because there's 2 pi radians in a circle, so 2 pi radians, when we're doing this, the 2 pi and the 2 pi cancel out, so we just get 12 or 15 radians, which is, like we discovered, 0.8. Okay, almost there. Clear all, and now let me move on to the 9th slide, or 8th slide. Okay, the 36-inch tires on a pickup truck have a circumference of 9.42 feet. To the nearest whole rotation, how many rotations must the tire make for the truck to travel 2 whole miles in a straight line? So this is just testing unit conversions because you want to make sure that you're not like, I don't know, doing feet times feet on the numerator while like completely messing it up. So the way that like a lot of times we taught in school, which is I guess like it's a pretty safe thing to do, so I'd recommend doing it, is just do it all in like one line and do it like this. So like over here we have our 2 miles. Then we want to have our first conversion factor, which is feet to miles. We want to have feet in the top hand and miles in the denominator because we want the miles and the miles to cancel out here. So 2 miles times 5,280 feet divided by 1 mile. But now we want to add our one more step, which is 1 rotation divided by 9.42 feet, because that's what we want at the top at the end. We want our answer to be in rotations. So then we divide that, and then that's our last conversion factor. So we can just multiply that out, and we'll get about 1,121 rotations. And to make sure that your units conversions are right, like over here we can see that we want rotations as our final answer. And over here we got rotations because all of our units, miles times miles, feet times rotations times feet. We had feet cancel out with feet, miles cancel out with miles, so all we're left with is rotations. So that's why doing like actually putting out all the units is helpful, because if you don't, you could actually do something like miles times feet, and then you somehow get miles squared rotations in the numerator, which just wouldn't make any sense. Okay, we're almost there. Okay, my audio cut out my entire thing cut out for some reason, but here, we're almost there. 2 more questions. So in the given system of equations, A is a constant. The graphs of the equations in the given system intersect at exactly 1 point, xy, in the xy plane. So what is the value of x at this intersection? So we're given the equations y is equal to 2x squared minus 21x plus 64, and the second one is y is equal to 3x plus a. So what we want to do here is we're going to set these 2 equations equal to each other because that's where they're going to intersect. So if we do that, oh yeah, and there's a small mistake on this in the next question. This is supposed to be a minus sign right there. So 2x squared minus 21x plus 64 is equal to 3x plus k. So if we subtract all the things on the right hand side to the left one, so we get a positive x squared and one side equal to 0, we have 2x squared minus 24x plus 64 minus k, not plus, sorry about that, is equal to 0. So what we're going to do here is if we look at a quadratic formula, what we're looking for is 1 point of intersection. But the quadratic formula gives 2 points, like 2 different solutions because of this plus minus right here. Like let's say you have 2 plus 5 or 2 minus 5. So to not have like multiple points, we just have this entire discriminant, like we just assume it to be 0. And that won't mess with the actual thing. That won't mess with like the value that we have for like a or k. I called it k over here because I don't want to like repeat a here and then a here. So that won't mess with the value we have because we only see k as our c, but the only place c appears is in the discriminant. So that means that we can just treat this as 0 because that's the thing that gives us 2 solutions, but we only want 1. So we just have negative b over 2a right here. And then with that, negative b plus minus 0 divided by 2a, we can just plug our values in. So b is negative 24, so negative 24 divided by 2 times 2, which is just equal to 24 over 4, which is 6. And you can also do some stuff with this on Desmos. So we can go to Desmos. We have 2x squared minus 1x plus 64 is equal to y, same thing. And then y is equal to 3x plus k. Let's add our slider for k. And you see how we can slide it down until we get like something close. So like let's see how close I can get. So what if I go like right here? Oh wait, this is supposed to be 94 or 64. Yeah, so negative 9 is a bit off. Negative 6.5 is a bit off. It seems like 8 is where it actually hits. And if we click it right now, we see that we only get, because like there's only one gray dot, that means that there's only one point of intersection. Or like right here, if we move it to like negative 3.7, we'd see two different points. But at negative 8, we only see one point. So that means if we go back to negative 8, let's just manually type this, negative 8. We click on it, click on the intersection, 6, 10. And 6 is the x value which we were looking for. So you can either use this to, like, if you're in a rush, you can use this, or you can just like double check with this. And now let's go back to our last question. I'll move this a bit. So two spheres have a radii in ratio 12 to 13. The difference in their surface area is 400 pi square inches. If the volume of the smaller sphere can be written as v pi, what is the value of v? So so we have that the ratio is 12 to 13, right? So because we don't know if it's 6 to 6.5 or 24 to 26, let's just add like another constant, like 12k, 13k. So then we have like a filler number. Like let's say k is 1/2, then we'd have 6 to 6.5. If k is 2, then we'd have our 24 to 26. So that's why right here, we have little r for the smaller sphere, big R for the bigger sphere. So we have r is equal to 12k, or little r is equal to 12k, while big R is equal to 13k. So taking the formula for the surface area of a sphere, which is 4 pi r squared, we have 4 pi big R squared minus 4 pi little r squared is equal to 400 pi. And then if you notice, we have 4 pi here, and then 400 pi is just equal to 4 pi times 100. So we can take out a factor of 4 pi on both sides. So we're left with big R squared minus little r squared is equal to 100. So then we replace the big R, little r with our actual values. So we get 13k, all that squared minus 12k squared is equal to 100. Simplify that. So we eventually get 25k squared is equal to 100, which means k squared would be equal to 4. So k is 2. So our little r, our little sphere's radius would be 12 times 2, which is 24. So now we have to find our surface area, or the volume of the smaller sphere. So v pi would be equal to 4/3 pi r cubed, which is in your reference sheet. So then we can take out a pi from both sides. We don't need that. So v is equal to 4/3 r cubed. So this should say 24, not 48. So v would be equal to 4/3 24 cubed. And if I put that in my calculator, because I made a mistake. Oops. We get 18,432. So yeah, that'll be correct on the answer sheet. That's my bad. I did it on the slides here. But yeah, so those were all 10 questions on the worksheet. If you need any extra help, I can go over it. You can just find me at Kitty Hawk or any of our wonderful math tutors. And I'd say, like, I've taken like the SAT. I'd say your biggest thing is these questions were pretty. The thing about these questions like I literally searched up for the hardest SAT questions math, and I picked these questions. But on the actual SAT, a lot of the questions are gonna be like, there are gonna be some questions that are harder than this. I won't even deny it. So you have to be like a bit ready for that. I just couldn't find like any like good that like replicate it. But a lot of the questions that you're gonna see are gonna be way easier. And what that's gonna let you do is you can just like blitz through everything with Desmos. So that's my strategy. Try not to, because you're gonna be prone to making mistakes, and algebra is gonna take like a lot of time. So just like blitz through everything with Desmos. Like if you have anything with lines, circles, graphs, like you're gonna get a lot of lines, circles, graphs, tables. So just do all that in Desmos with like some, like you're gonna have a few questions obviously, but yeah. Oh my god, low battery. So thank you for listening, and that's it.